Hello everyone. Today we are starting with the fourth unit, that is bending moment and shear force. This unit is the fourth unit of our strength of material chapter, and this is very important topic where you will be getting around 30 marks questions will be asked from this unit. Okay, let's start with it. So before understanding what is bending moment and what is shear force, we will understand what is cantilever beam or types of beams, or which are the types of beams in is used in the structures, and what type of loading is been applied. Okay, first we'll understand, then we'll move for the shear force and the bending moment. Cantilever beam, a beam which is the beam which is fixed at one end and free at another end is called as cantilever beam. Okay, okay, you can see here it is fixed at one end and it is free at another end. It is free to rotate, okay, in this direction or in this direction. Okay, next is simply supported beam, beam which is supported and the both the ends, where the beam is supported freely on the both the ends. It is not fixed, it is just resting over the two supports. Okay, it is means what? It is resting freely on the supports. It is not rigidly fixed with the supports, like in this case of the cantilever in the pavo, right? Here it is rigidly fixed. Here it is just placed above the supports at the two ends. That is called simply supported. Next is overhanging beam. In the case of overhanging beam, okay, the one end of the one end of the beam is extended beyond the supports, okay, like a cantilever. That beam is called as overhanging beam. The beam, this type of beam might have one overhanging, or might have the overhangings on the both the sides. Okay, in this case, in the shown figure, it is right hand side overhanging. Okay, it might be on the left hand side or it might be on the both. Like here in this case, it is one and two overhangings, right? It is extended beyond the simply support. Okay, this is what overhanging is. Next is fixed beam. When the both the ends are fixed or built inside the wall, built-in wall, then that beam is called as fixed beam. Okay, next is the continuous beams, the beam which is provided more than two supports. Okay, more than two supports, that is known as continuous beam. Okay, next is types of loading. First one is the point load or the concentrated load. A concentrated load is a one which has concentrated to act at a point, where the load acts at a point on a beam, not all along the length of the beam. It acts at certain point or at a specific point of the beam. That type of loading is called as point load or the concentrated load. Next is uniformly distributed load. Okay, the beam in which the load is been spreaded along the length of the beam at a uniform rate. Okay, the loading is done along in the uniform rate along the length of the beam. then such type of loading is called uniformly distributed load. The load is distributed full along the length of the beam, and the load is same throughout its length. Okay, such type of loading is called as uniformly distributed load. In the next type, it is uniformly varying type of load, where the loading is going to vary along the each section of the beam, along the length of the beam. Okay, such type of beam is called uniformly varying, where the rate of change of loading will be uniform, but it will be increasing. It will be not constant, it will be going on increasing in one point to the another point of the beam. Okay, that type of loading is called as uniformly varying load. So now we'll come to what is shear force and what is bending moment. Okay, so when what is first we'll try to understand what is shear. When two object, okay, rub to each other, that time it is called as shear. The friction which is caused by that two objects is called as shear. In the same case, okay, in the same case also, when there is a beam, okay, and you apply forces in the opposite directions, then at this point there will be a shear force acting. Okay, it is meant by there will be a, because the one load is trying to push the beam downwards, and the another loading is trying to push the beam upwards. So at certain sections or certain point where beam will try to have a shear acting at that point, and that point is called as, and the force which is applied over that beam is called as shear force, and the point is where the shear will be acting. That will be the point where shear will be acting. Okay, so this is what is shear force in the beam. Okay, now how to calculate this shear force in the beam, we'll try to understand. It is the algebraic sum of the vertical forces at any section of the beam to the right or the left of the section of the beam. Okay, we'll try to understand what the definition is trying to say. Okay, if this is your beam, okay, this is your beam, okay, and it is said that algebraic sum of vertical forces, we consider that the downward force is positive and the upward force is negative, okay, of the section drawn. Okay, it might be the section left of the section or the right of the section. Okay, if it is to the left of the section, okay, suppose we consider positive force. So when we have difference in signs, then we'll be having a algebraic sums, right? We'll be having a algebraic sums. So it is called as algebraic sum of the only vertical forces, no horizontal forces. Okay, only the vertical forces. Okay, that is called as, at any section of the beam to the left or the right of the section of the beam is called as shear force. Here understand, we are doing the algebraic sum of the vertical forces. Okay, we are doing the sum of vertical forces in the shear force. Okay, the next is bending moment. Okay, what is bending moment? When we apply the loads or the forces over the body, I have said in the first unit, when you apply the load, there is a moment caused. Okay, whenever we apply the force on an object or a body, the body tries to have a rotating effect, that is movement. In this case, in the beams, okay, when we apply load, okay, when we apply the loads like this, Okay, these are your supports, and when you apply a load, your the beam will try to have a movements in this way. So due to that, there will be a bending cost. So due to that movement, a bending is caused. So it is called as bending moment. You can see it as BM. Okay, due to the movement, that is because of the application of forces where movement is caused. Due to that movement, the beam or the structure will bend. So it is called as bending moment. Okay. So now, how to calculate this bending moment? We'll try to understand by definition. The algebraic sum of the moments of the all the forces acting on the left or the right of the section of the beam is called as bending moment. Here we are going to have do the algebraic sum of the moments. Okay, what is how we will calculate the moments? It is the force into the distance, perpendicular distance at the point where the force has been applied. Okay, and from where we want the movement, that distance into the application of force will give the moment. Okay, so that moment, when you do the summation of those moments about particular section, that is called as bending moment. Okay, so for that we have to first understand to for the calculation of the bending moment, to first understand the sign conventions that has to be fixed. Okay, uh, it is not a hard and fast rule that you have apply the same uh, sign conventions. You can apply the vice versa of these sign conventions. Sign conventions for the shear force. Okay, in the shear force, okay, the upward force, when the force is applied upwards in the left of the section. Okay, if this is your beam, okay, and you draw a section like this, okay, XX, and the force applied is upwards. Okay, to left of the section, then that force is called as positive force. Okay, and if to the right of the section the force is acting downwards, this is the left side and this is the right side of the section. So when on the left side, if you're taking consider left side, the positive forces are which are acting upwards. The same thing we are showing here. The force is upwards on left hand side of the section, then it is positive. If you are considering the right hand side, then if it is acting downwards, it is positive. That shear force is positive. Okay, and the remaining will be negative. That if take the beam, you take the section, and you on the left hand side your force is acting downwards and your force is acting on upwards in the right hand side, then these forces will become negative, right? You can see in the this sign conventional diagram, right? The on the left hand side the downward forces are negative and the upward forces are positive. Consider one section, the right or left. Don't interchange every time while solving the problems. Consider one, and we will be taking the left hand side and we will be solving the problems. Okay, it becomes easy to start from the left hand side and go to the right hand side. So we will be taking considering the left hand side sign conventions. Okay, that is on the left hand side the upward forces are positive. Okay, and then downward forces are negative. Okay, that is the sign conventions for the bending moment. Now here we'll try to understand this sign conventions. If you see, there is a beam AB At the midpoint C, there is a load applied that is 1000 newtons. So if you are applying 1000 newton and there are two supports and they are at equidistance, then the load will be distributed into two parts. That is, whatever the force you are applying, the beam will resist the same load, okay, in the opposite direction. So this will be RA and RB will be 500. Okay. Okay. So if this is 500, so how we will calculate which is positive and which is negative shear force? How to calculate the shear force about any point? If you want the uh, shear force along this cut section, then what is to the left hand side? Upward forces are called positive. So what is the force, upward force? It is 500 and it is positive. So at the section XX, okay, the shear force is positive 500 Newton. Okay, and if we take the right hand side, okay, this is how much downward forces on the right hand sides are positive, right? 1000 plus 1000 minus, because this is upward force and in the right hand side of the upward force are negative, so we'll be taking minus 500. So what will be the value here? Here it will be 500 only, but it will be positive because the greater number sign. So here also at any point, okay, the shear force is plus 500. Okay, this RA and RB are the supports. Okay, because you are applying 1000 Newton of force, okay, same load will be resisted by these supports. So they are the forces at the equal distance from the both the supports, so the force will be divided between these two supports equally. So 500 and 500 for the each supports. Okay, now going next to the bending moment. So what is bending moment? Is the algebraic sum of the moments. Okay, so you can write the sign conventions for the bending moment in two ways. If due to the load, okay, if the moment is in the clockwise, then it is positive, and if it is anti-clockwise, then it is negative. Or one more way we can say that, okay, if your beam is sagging like this, okay, to understand sagging, to keep in the mind, draw this smiley face, okay, and this shows the positive sign, right? This is what is sagging is, right? This is what is sagging is, so it is positive. The sad face, this is your face, and this is your hogging. When it is sad face, it is called hogging, okay, and it is negative. You can see here same thing you are trying to keep in the mind what is hagging and what is sagging. For that we have shown the happy and the sad face, and if it is sad face then it is negative force, so the sign convention will be negative. Whichever easy to you to understand, you can consider out of these two. Don't mix up with two, take any one and start for the which will be helpful for this calculation of the bending moment and the shear force. We'll try to understand how to calculate the bending moment and what are the um, fixed formulas for regular uh, beams, what are the formulas for to calculate the bending moment and the shear force. Okay, we'll try to find it in the next class. Okay, thank you.